Greetings, ladies and gentlemen. As we know, in the industrial boiler system, the Deaerator tank plays a particularly important role. This component helps to remove oxygen present in the feed water, minimizing the corrosion of iron and steel metals in the boiler due to oxidation. This process can cause damage or pitting on metal surfaces, leading to reduced lifespan of the boiler and increased maintenance costs for the plant's boiler system. So, what are the structure and operating principle of the Deaerator? Today, in this video, we will explore the structure and operating principle of Deaerator tank. The Deaerator is designed with two main parts: the lower cylindrical body, which is the water storage compartment, and the upper cylindrical body, which is the deaeration column. The deaeration column is divided into multiple levels with trays. These trays are used for monitoring, cleaning, and maintenance. The feed water enters the Deaerator from the top of the deaeration column. The heat supply pipe to the tank is introduced from the bottom of the deaeration column. At the top is the vent pipe to release gases, and at the bottom is the water storage tank after the deaeration process. The bottom of the tank is connected to the suction pipe of the feed water pump to supply water to the boiler. On the body of the storage tank, there are sight glasses to observe the water level inside the tank. And here is the flow sensor. Below is the stand supporting the Deaerator tank. And the platforms are arranged to facilitate operation, cleaning, and maintenance. Water from the economizer at a temperature of 80 to 85 degrees Celsius, not yet deaerated, is introduced at the top of the deaeration tower and flows evenly through the levels of trays. At the same time, the steam supply pipe is provided at the bottom of the deaeration column. The steam flows upward, while the water to be deaerated flows downward. The heat source entering from the bottom of the deaeration column heats the water, making it hot and converting it into steam that rises to the top. At this point, the water coming from the economizer flows through the trays and drips downward. In the process of countercurrent motion, the steam transfers heat to the water, raising its temperature to the boiling point corresponding to the pressure of the Deaerator tank. At this point, the partial pressure of water increases. The steam condenses upon contact with water and is recovered into the water storage tank below. The water in the storage tank, after deaeration, is fed into the boiler at a temperature of approximately 102 to 104 degrees Celsius. Meanwhile, the partial pressure of the air decreases, and the non-condensable gases rise to the top and are vented out through the vent pipe. In other words, the operating principle of the Deaerator for feed water to the boiler is based on the countercurrent motion of water and steam, which balances the water pressure and the pressure in the deaeration column, lowering the air pressure to allow gases to escape into the environment. This is the entire operating principle of a Deaerator. In practice, there are many types of Deaerators with different structures, but they generally use the same principle for deaeration. We hope this video will help the audience understand more about the operating principle of the deaeration component in the industrial boiler system. Comments and feedback from viewers will help us improve our product further. Thank you.